Today we're going to talk a little bit about work and power. And in your note in your packet, these notes start on page 4. I want to put this together because some people had some problems getting started this week. So hopefully this will help. Okay, so run through the work and power notes. So what is work? Work is the transfer of energy through motion. So it's how we move energy from one type to another type, and it happens when something changes, when an object moves. So an object falling, an object sliding, etc. It is a force over a distance. So because something has to move to do work, we have to apply a force to get it to move. So think about pushing a box across a room. You're applying a force as you push it across the room, and therefore you're changing it from a stationary state to a moving state. You are creating kinetic energy. You are creating energy in doing that. We'll talk more about energy later. So this is an example of work being done. Notice that the force is in the same direction as the motion. The robot is pushing to the right and the crate is moving to the right. In this case, however, no work is being done. That is because, well, at least not until he lowers her, right? But as they slide across the ice, no force is being applied to keep them moving in that direction. They're sliding due to, what is it? Inertia, right? There's no force pushing them. They're sliding due to their inertia. No friction is there to slow them down, or minimal friction anyway. So they are sliding due to their inertia. That means no force is being applied in the direction that they're moving. They're moving that way because of inertia. Force is being applied up to hold her up. But notice she's not moving up or down. So because there's no motion in the direction that he's pushing her, no work is being done by the man on the woman. Similarly, we can say how much work is being done on the man by the ice. Well, the ice is pushing the man which way? Up, right? Since there's no friction here, since there's he's not having to be pushed to go forward or slowed down, the ice is applying a force directly upward. He's moving forward. Those are in two different directions, so no work is being done. When is work being done here? Is it then? Right now is work being done? There. Is work being done when, right there, when he's lifting? Yes. On a lift, there is work being done because he's applying an upward force on the bar and the bar is moving upward. Therefore, work is being done because force and direction and the distance moved are in the same direction. However, when he's holding the bar above his head, no work is being done because no distance is being moved by that bar. So let's do a practice problem with Barrett. Barrett's backpack weighs 30 newtons. How much work is done on the backpack when he lifts it 1.5 meters from the floor to his back? Let's write out our givens. The force is 30 newtons, right? Because weight is a force. The distance is 1.5 meters. We're looking for the amount of work. So let's write out our formula. Work equals force times distance. The work, the force is 30 newtons. We take that over from our givens. And the distance is 1.5 meters. This gives us a total work of 45 joules. 45 joules. Our second practice problem has a dancer lifting a ballerina and then moving forward. Notice there are two different directions here, up and forward. Let's write out our givens. Mass is 40 kilograms, and there are two distances, right? The one upward, 1.4 meters, and the one forward, 2.2 meters. Whew, writing with a mouse is tough. Anyway, so notice that the 1.4 meters is up and the 2.2 meters is forward. We're looking for our work. Let's go ahead and write our formula for work. And let's go ahead and figure out what is the force of lifting this ballerina. Well, isn't the weight of the ballerina the force? Isn't weight a force? So let's figure out the weight of the ballerina. Weight is mass times gravitational acceleration. So 40 times 10 gives us 400 newtons. So we can say the work is 400 newtons multiplied by 1.4 meters up, right? Because the force, the weight is going down, so the dancer has to push the ballerina up with 400 newtons of force, and she moves up 1.4 meters. So that gives us a total work of 560 joules while lifting up. But how much work is done as he walks forward, as the dancer walks forward holding the ballerina? Well, which way is he pushing the ballerina? Up. And which way is he moving? Not up, right? That 2.2 meters is moved forward. He's walking forward while holding her up, and therefore no work is done because those two forces don't go, that force is not in the same direction as the motion. Power. Power is the rate at which work is done. So work is changing energy, right? It's making one type of energy change into another. So think about drying your hair. When you dry your hair, you're changing electrical energy into thermal energy. So the electricity is turning into heat. How much power does that generate? Well, the faster that your hair gets dried, the faster that that electricity is turned into heat, the more power is generated, which is what we see on the side of the hair dryer so often. It might say 1,000 watts. It might say 1,300 watts. Or if you're staying at a hotel, maybe it says 300 watts and it takes you 2 hours to dry your hair. Right? Notice the lower the power, the longer time it takes, the longer the time it takes to get the work done. So again, power is work divided by time. It is work divided by time because it's the rate at which work is done. We could also rearrange our work formula to say that power equals force times distance divided by time. We use the watt, but you may have also heard the term horsepower. 1 horsepower is also a measure of power. And if you go to your power stair climbing lab and read the beginning closely, you will see that we've given you the number of watts in a horsepower. Hint, you need to use that for some of the questions on the back. Let's do a couple power examples. Two people each weigh 200 newtons climb a flight of stairs that raises them 10 meters vertically. Who did more work? Let's start with that. Who did more work? Well, if they went to the same height and they have the same weight, that force, 200 newtons, is what it takes to lift them upward. This is the distance. 200 times 10 means 2,000 joules of work for both of them, right? But if person A climbs the stairs in 20 seconds and person B climbs the stairs in 40 seconds, who generated more power? Well, that would be the one that did it faster, right? So that would be person A. So they did the same amount of work, but person A generated more power. Let's go to the next question. This is practice problem 4. A person does 500 joules of work in 10 seconds. How much power did they generate? Well, work is 500 joules and the time is 10 seconds. So 500 divided by 10 gives us 50 watts. And then for practice question 5, in 5 seconds you lift a 5 Newton box 4 meters off the ground. How much power did you generate? We're going to use our force times our distance. 5 times 4 is 20. Divided by 5 gives us 4 watts. And that is it. If you would like, go watch the work, energy, and power video from Crash Course. It is quite good. And I will be available by Remind and by Zoom if you have any questions.